So finally we meet personally. We had 2 lectures before, now the lecture number 3. I'm interested how you progress in your research papers. So there is a PMBOK book, which I mentioned you a few times, and they have 10 knowledge areas, so that's why we're lucky to have 10 lectures as well. We already discussed integration management, where managers are supposed to integrate things together to make sure the project doesn't fall apart. The second lecture was about scope management, where the project manager is supposed to control what do we do. The scope is what we do, what kind of problems we solve, what kind of tasks what kind of code we write, what kind of features we implement, the bugs we fix. All of this is scope. So today it's going to be about time. The project manager is supposed to control time. And I told you last time, actually a few times already, that the job of a project manager is not to make things happen, but more like to know how they happen. So the project manager is the person who always knows what's going to happen in the future. The project manager knows how much time it will take, how much money we're going to spend, how much more bugs we're going to fix. The manager knows what's going on. It doesn't mean that the project manager is responsible for what's going to happen, because he's not or she's not a code writer, not a programmer, not a DevOps engineer. The project manager only looks what's going on, checks all the metrics, all the numbers, put the pieces together, and then tells everybody, it's going to take 3 more months and then we finish. And these numbers should always be in the hands of a manager. So time is one of the aspects which the project manager needs to put together in order to know what's going on. And as before, as usual, I will give you questions, 8 questions, see how they answer them. But before that, I will show you one picture, 2 pictures actually, which I got from this PMBOK book. On the left side, this diagram shows how they understand the entire project management. So first of all, they believe, and we all believe, that the project is something that starts and stops. We discussed that in the first lecture. The project is not a continuous activity. The project is something that stops now and then starts now and then stops in a few months or a few years, a few days. So the starting point is here, the ending point is there. And then there is a cycle. There's a cycle of 5 process groups. They call it process groups. On the left side, you see initiating processors. Yeah, there. Initiating, so you start something. And then you do planning, so you plan how you're going to do this. And then you execute what should be executed. And then at some point of time you close. And you do this with all the aspects of management, with scope management, with time management, with stakeholder management. So they divide the entire management into these 2 dimensions. Horizontally, in this way, they have, like I said, initiating, planning, executing, monitoring, and closing. 5 activities. So let's say we're interested in the scope. So we are, let's say, actually in big projects, it's a good practice to have a number of project managers. One project manager is responsible for scope management, another one for time management, another one for cost management. So we may potentially have 10 project managers, 10 aspects of project management, 10 managers. If the project is huge, if, for example, you're trying to send astronauts to another planet, then most probably you're going to have a number of project managers. And each project manager, there will be a chief project manager, and each project manager will be responsible for each aspect of management. One only for scope. Like, what are we going to do? What is the work breakdown structure? Who does what kind of bugs we fix? What kind of scope, what kind of code we write? It's one aspect. I don't care about time. I don't care how soon you're going to do this. I only care about what we do. Another guy is responsible only for time management. So I plan stuff on the timeline. So I only know when it's going to happen. I don't care what you do. You write code or you fix bugs. It doesn't matter. And these 2 people or 10 people, they all going to be doing 5 activities. They're going to initiate scope management. They're going to do plan how we're going to do scope management. They're going to execute scope management. Then they're going to monitor how good it works, and then it's going to be closing. So we close. Okay, now we've done, the scope is more or less complete to some point, and we start again. And there's on the vertical axis, we have knowledge areas. Like I said, this is scope management, this is time management, this is cost management, this is quality management. So these are the things which we do. So this is the 2-dimensional matrix of the process groups, as they call them: start, monitor, execute, and close, and the 10 10 knowledge areas. That's, in my opinion, it covers everything which we may cover in the area of process of project management. Okay, that's enough. It's just to give you a taste. You don't need to remember that, but it's good to know. Actually, this is my favorite picture in the entire PMBOK. So this one, I just remember it because it covers, if you go deeper and look what needs to be done, then you can always say, okay, I'm doing right now scope management. So I want to do something. Okay, what do I need to do? When I plan, I need to do these 4 activities. I need to remember 1, 2, 3, 4. You can read it yourself. We're not gonna go deeper into these details in the lecture because I'm not trying to bore you down, but instead make it fun. Now we go to the questions. 8 questions as before. Take your notes, your block notes, and write them down. Question number 1, you ask a programmer how many days, you're the project manager. In all of these questions, you're the project manager. So you ask a programmer how many days will it take to implement a new feature? Which answer you would expect and appreciate most of all? An exact number, 12, there's days, or the programmer says from 10 to 14.
We have a different question starting with the PDF file.
Yeah, I know. I changed a little bit. Yeah, of course. Yes. There was just a trial version. So now it's the ultimate version. But some of them are the same. So this answer number 3, more than 10. That's the answer. And the answer 10, 12, 14, whatever it means. We're going to discuss later. So choose one. Which one do you as a project manager would appreciate more and like more? Second question, a customer asks you to estimate how long will it take for your team to implement a new feature. So what do you do? First, you call a meeting to discuss. So you call everybody, all the programmers, and say, okay, now the question is how much? So we all contribute and we say something. Answer number 2, you ask your architect. So you call the main guy, the main technical guy, and say, okay, how much? And then that person gives you the answer. Number 3, you send out an Excel spreadsheet asking all programmers to fill it out. So you don't talk to them, you just send an email. You just say, hey, make me an estimate. And they return you back the numbers. Pretty non-interacting way of collecting the numbers. And finally, you estimate yourself. You just give the number to the customer because you're the project manager, so you know the details, you know the numbers. Number 3, a potential client asks you how much would it take to make a Tetris mobile app. What answer would be the most accurate? A customer asks you, potential client, keep in mind. So it's not a project yet. We haven't started yet. We're just asking. So first answer, what answer from you would be the most accurate? What do you think? First one, a month, more than a month, from 1 week to 4 months. See the difference, 1 week, 4 months, or until you run out of money. That's also a possible answer. So which one do you think is the best one if you are a professional project manager? Question 4, some of your programmers complain that they sometimes don't know what to do, which leads to wasted time and frustration. It very often happens in software teams. They just come to you and complain, you don't tell us what to do, we don't know what to do, we do different things, so what's going on in the project, we're not sure. So how do you fix that? The fix number 1, you use sync up meetings every morning, sometimes call them daily stand-ups. Maybe you've heard about that term. So daily stand-up, everybody stand around and they talk, discuss what's going to happen this day. And that kind of helps them to synchronize and they will know what's going on. Answer 2, use ticket tracking system. So in the ticket tracking system, the details will be there. Answer 3, use regular emails to everybody. You just email them. They don't know what to do. Okay, we're going to email them every day or every hour, every week. And finally, use shared Google spreadsheet with the project schedule inside. So they just open the spreadsheet. There's like we have the spreadsheet for all the groups. So they have the spreadsheet, all the tasks there. So everybody knows who is doing what. Which option you would choose being a project manager? 5. There are 5 activities taking 2 days each. Remember, we're doing time management now. So how long will it take how long the entire project will take? 5 activities, 2 days each. Let's say 5 bugs we need to fix or 5 features to implement. We know that the duration of each activity is 2 days. So it takes 2 days for this one, 2 days for this one, 2 days for this one. There are 5 of them. So how long the project will take? 10 days, 5 days, 2 days, from 2 to 10 days. So what is your answer as a project manager? Question 6, what do you see on the picture? Here's the picture. What do you see there? Do you know what it is? If you are a professional project manager, you would immediately say what it is, but we are still students, so there are 4 options for you. Gantt chart, critical path method, project schedule, or PERT diagram. Choose one, and we will discuss. Question 7, a customer asks you to complete the project 1 month faster. So now let's say it should take 3 months, but the customer comes to you and says, can you do it in 2 months? Not actually can you, but the customer says, we need to do it in 2 months, not in 3 months. So how can you do that as a project manager? What instruments you're going to use? The instrument number 1, smoothies and free snacks. So you give them supposedly to your team, and they start working more actively, and they complete in 2 months instead of 3 months. Option number 2, carrots and sticks. So you punish them, and then you give them some bonuses. 2 instruments. Or you use crashing and fast tracking, whatever it is. If you know, you can choose that one. And finally, the option paying and praying. Maybe you know that wording. It means you just hope for the best, give as much resources as you can, and then hopefully the miracle will happen. So which one would you go for? Option 8, question 8, which of the following belongs to the SMART acronym? Pick one. Magnificent, they're all, smart, they go for the first letters, obviously. So pick one. This is M, this is A, this is R, this is T. So which one do you think out of these 4 actually belongs to the SMART acronym? Who knows about this acronym, SMART? Oh, good. So you can clearly answer this question. All right. So now we're getting back to the right answers. Let's see how many of you managed to. Well, again, remember, it's all opinionated, so the right answer is my right answer, so some other books or maybe some teachers can give you the other right answers, but my answer is the following. So the question number 1, how many days it will take to implement new feature? The right answer is this one. And we are talking here about an estimate which is supposed to come from a programmer. From anybody. So anybody in your project, in order for you as a project manager to help understand how long it will take to implement something, we're talking about time now, not about cost, not about their scope. We're just asking, how long will it take for you to do? The answer which is coming back should be the time units, hours, days, whatever. And the right way to estimate, well, the most popular way to estimate things right now in software development domain, as far as I know, is using 3-point estimate, so-called. 3-point, estimating by 3 points. We ask the people to estimate, and they deliver the best case estimate, the worst case estimate, and the most likely estimate. So I'm saying I'm going to implement this feature. In the best case, it's going to take 10 days. In the worst case, it's going to take 14 days. But most likely, it's going to be 12 days. How do we turn this into the actual number? We put BC plus 4 multiplied to ML plus WC, and all of this divided by 6. So then we get the actual number. So what is going to be the number which we can use in the planning later on. And usually we ask people, when we ask them to estimate things, we ask them to make these numbers, these and these, as pessimistic and as optimistic as possible. So these are actually not good numbers, 10, 12, and 14. This is, if a programmer would give me this estimate, I would question that person whether they understand what is 3-point estimate. So I would say, are you sure that in the worst case it's going to be 14 days? What if the framework which you're using is not going to work? What if you got sick? What if you get a vacation? What if the fellow programmer who works next to you will just quit the company? In this case, still going to be 14 days. In this case, the answer will be, no, it's not 14, it's 40 actually days. And then I would say, okay, now it's reasonable. Now it's the worst case, so I can take this number and use it. And the best case, I say, are you sure it's the difference is so small between these two numbers, 10 and 12. It doesn't look real. So you should think about whether in the best case, maybe you just opened this bug and it's fixed in just one line of code or just a few lines of code. Maybe you get lucky. So the best case should be like 2 days. So from 2 to 12 to 40, this sounds reasonable to me. And then you use these numbers, do the calculations, and then you get the number which you can use for planning. So this answer is definitely not right. If the answer is exact number, then the estimate is, it means that the programmer is not taking into account all the risks and uncertainties, which is not an estimate. This number we can only get when everything is done, when the result is there. So this number, this difference is, we cannot use this interval because I don't know what is 10, what is 14. So I don't know where is the middle between them. So how worst is the 14 and how best is the 10? If I have the number 12 between them, I know where is the balance, where between these two numbers we stay. And usually we don't stay in the middle. Usually we stay somewhere close to the best case. So the worst case usually goes up and up. And that's okay. It's okay to get very negative estimates from programmers. It's all right to have that. There's no problem with that. So don't ask as project managers to give, don't ask your programmers to give the estimate with very high precision. It only leads to mistakes. Instead, you ask them, don't make it precise, make it imprecise, make it very improvise, be creative and think about very negative scenarios. And then give me the numbers. Then it's my job as a project manager what to do with these numbers. Your job is to give me the numbers. And of course, these estimates, it's like a joke. Of course, everything is more than 10. It's a million is also more than 10. So actually, in this case, the programmer just doesn't want to take any responsibility for the estimate. Just says it's going to take more than 10. That's the only thing I can say. In this case, I would definitely go back to the programmer and say, do it again. Think again. What is the worst case? Give me the number. Just more than 10, it's not an estimate. So that's how we do it. We call it 3-point estimate. Okay? That's first step in the estimation process. Second, the customer asks you to estimate how long will it take for implement new feature. What do? The right answer is, in my opinion, is this one. So first of all, you call a meeting. When we call a meeting, which is most people do, which is most teams do, they just call a meeting because they don't know what is 3-point estimate. They don't know how to use these numbers. They're not professional project managers. They don't want to take a responsibility on making this planning and estimating decisions, so they call everybody. And they say, let's make a decision together. And in this discussion, which sometimes they use the technology, the instrument, which is called planning poker. Maybe you've heard about it when they use the cards and they. But the bottom line is that it's done in a group activity. So all together they discuss. In my opinion, this may be a good approach, but only after you collect the numbers. So people should make estimates without talking to other people. They need to estimate in isolation. They need to estimate to put their own thoughts there, not listen to others. So taking everybody in the group and discussing in the group is not, in my opinion, a good approach in this particular very sensitive area. So people need to think by themselves. And when they finally give the numbers, then you maybe can call a group and say, for example, they give you the numbers, usually how it happens. Usually we build, before a customer asks to estimate how long. So before, if I would be the project manager, before starting estimating time, I would estimate scope. So it's difficult to say what will take long because we don't know what is the scope. So probably in this question, already we know that's a new feature, so probably somebody made some decomposition of the feature. So probably we have something like this. This feature will take, let's name the feature A. So the feature A will be, there will be A1, A2, A3. So there will be 3 elements which we need to estimate. Then I draw this picture. I say, I have, let's say, 3 programmers. I say Jeff, and I have Mary, and I have, I don't know, some dude. So I draw them like this. And I say, give me 3-point estimates. And then the Jeff says 10, 12, 40. And then here 7, 10, 30. And then here 5, 7, 12. And then I say, here are the other numbers. I say, let's, for example, 11, 15, 100. And then here we have 2, let's say 3, 4, and then 7, and some other numbers. So in this case, when I receive this information, that kind of data, then I look at it and I understand that the Jeff estimate of this particular element A1 is very far away from what this dude gave to us. Very far away. And that's a very good motivation for a meeting. In this case, they probably didn't understand well what is A1. Because this person gives me the result will be somewhere around 25 maybe. And here we have maybe what? Maybe 4.5. So between 25 and 4.5, it's a huge distance. It means a misunderstanding of the scope in most cases. Or maybe they're completely different in skills. One of them is a Java programmer, another is a DevOps expert. So they have no idea what is Java programming, for example. In this case, the DevOps person just gives the number randomly. And then we put them together and the Java programmer explains, no, it's not going to take 4 days, it's going to take at least 10 days. Think about it. We need to implement this, we need to install the framework, we need to study something. So it's going to take longer. And then the DevOps expert says, okay, yes, I didn't know that, so let me re-look into my estimate and give you different numbers. So this spreadsheet is what the estimate looks. I ask every programmer to give me 3 points, give me three numbers for each feature, for each element of the scope. And then I collect the numbers. If everything looks balanced, then I just calculate, I just get using the formula, I multiply and divide by 6. So I get the number for each feature, so for here, and then I get the average. So let's say Jeff will give us the 25, 12, and something like 8. So this is the total for Jeff, sum. There's going to be total for Mary somewhere, and there's going to be total for this guy. So there's 3 of them, I will put together. This is going to be the estimate of Jeff, for example. Total will be to 45, that's going to be 55, for example. Here it's going to be 19. And then I just do the average. And that's my estimate to the customer. But when I do all this, it's not only going to give me the average, but I can use all of these numbers also to have the best case, the most likely, and the worst case, because I put all the pieces together from all these people, and I will have 3 numbers for the customer as well. So I will give him the most likely estimate, I will give it a balanced estimate, and I will give 3 numbers. We will discuss it a bit later, why we may need to show the customer all 3 numbers, not only the middle line. So, calling a meeting in the beginning, it's a wrong idea, because when you call a meeting, you completely destroy this process. Yep.
Do always all other programmers participate in the implementation of the feature?
It's even better to ask people who are not implementing the feature to make an estimate. So it's better to, if I have, let's say, 3 programmers, and 2 of them only going to work with this, and the programmer number 3 is not going to participate, it's even good to ask that person to estimate for me, because it's going to be like independent external estimate.
But maybe he or she doesn't know.
Maybe, yeah. In most cases, it's going to happen. Yes, they don't know. But that's good, because they don't know the knowledge. They're only going to get the knowledge from the description of the feature. So all we said in the description will be visible to that estimator. So the estimator will give a best guess. And if the best guess is very wrong, then probably we misunderstand the scope. Maybe we need to sit down and think whether we properly understand the scope. So it's going to even test our scope definition. It's going to test our process in the project. In this case, I would even ask to estimate like this, to have that cross estimate. So that I would ask the back-end programmer to estimate the front-end feature, and front-end people also to estimate front-end feature, to see how they understand. So if there's going to be a very big distance between their estimates, then I will question myself whether everything is good in my project. So it's even better. So in general, not only in this case, it's in general very good to rotate people, to make sure that people are not just sitting on their domains, on the territories which they understand well, and they sit there and they provide you the information which they provide. It's better to test them sometimes and ask somebody else to look at what they're doing and give you some other numbers. And if you see the huge difference, then start asking questions. So why? Why these people are telling me that it's going to cost me 2 times more? While these people saying, no, it's going to cost 2 times less. Why it's going to, what's happening? So this is the spreadsheet which we built, and of course you don't ask your architect. Maybe it's not a bad idea if the project is extremely small and you have just one architect and maybe one programmer. But if the project is big, it's usually not good idea to trust one person. Of course, this one sounds like a joke, so this is not an option at all. You don't estimate yourself. We know about that. So the project manager should not substitute himself or herself in a place yourself into the shoes of a programmer. So don't expect you to be technically competent. Always expect something opposite. So expect your people are smarter than you, especially technically wise. So ask them about the information. So the right answer is you build the Excel spreadsheet and you ask programmers to fill it up.
Also, programmers inside one team or the whole company?
In the whole company. I would even call programmers from other team.
Like 300 programmers you should analyze.
No, it shouldn't be. You shouldn't involve many programmers. 3, 4 should be enough. So you don't involve 100 programmers to do the estimate. You just ask 2, 3, 4 people.
Basically, use one team. Just your team.
Well, let's say I'm a project manager, I have 5 people in my team, and they come and say, well, how much it will take? I will draw the spreadsheet, and then I send it to 2 programmers from my team and 2 programmers from somebody else's team. So I get 4 numbers, 4 columns. And then I look at these numbers. If everything looks balanced, then I say, okay, great, I can rely on these numbers. So 4 people, 2 independent people and 2 my people, they gave me more or less the same numbers. Good, so that's my estimate. It's not going to happen usually. So usually the problems lie in some estimates. This is what usually happens. In some lines, you will see very, very big disbalance. And this is the motivation for a meeting. But you don't start with a meeting. First, you collect the numbers. This is what the question is about. Okay. Next one. A potential client asks you how much you would take to make a Tetris mobile app. What answer would be the most accurate? That's a tricky question. So it's a real situation. A potential client comes to you and how much would it take to make a Tetris mobile app? So if you're really a professional project manager, like really strong and professional, this is your right answer. So you really say that. Because the scope is not defined. A mobile app known as Tetris may really take a year, 2 years, 5 years, 15 years of development. Look at the applications like Facebook. How long would it take for a regular programmer to write an application which does what the first version of Facebook was doing? So I can log in, I can upload my photo, and it will show in your timeline. How much time will it take for a programmer? 1 day, 2 days? Make a database, make a few screens, the login screen, the screen with the timeline, show the pictures, show the text. It's 1 day of work. It's not even a diploma work. It's not even a course project. It's a small weekend project. And at the same time, Facebook is still developing this application for the last, I don't know how many years, 10 years, 15, 20 years. So they keep developing the same simple application. It's the same Tetris app. But the more and more features are being added there. So imagine the Tetris application. In the Tetris application, one person is playing these elements, they drop down, everything is cool. This project is for, 2 days of work. What about the registration of the customers? What about multi-customers? What about the network connection? So what about account which I may have? What about competition with other players? What about, changing the colors, changing the layout, changing the sound, playing the sound, replaying the games, or many features can be there. And we don't know in the beginning how long will it take. So when the customer says how much would it take, it means if the definition of the scope is not clear like this, and it is not a clear definition of the scope, so usually we can say that we're gonna work as long as you have money, we're gonna develop. And it's not it's not wrong to say that. It's gonna be wrongly interpreted. I tried it a few times in my career, and every time I lost the customer because they think that we're trying to cheat on them. We're trying just to take their money. And it was very difficult for me to explain that I only mean well. So I'm just saying that we can start easily. We can start with a simple prototype, but then we're going to go and go and go. And you will pay us because the product will grow, it will become more valuable for the users, and everybody will like it. So we like it with the Facebook. So I was giving the example with the Facebook, but then the customer, I still lost the customer. It happened to me 2 times in my life. So I stopped saying that. And now instead of saying this, I'm saying, So this is the answer for really professional project manager, for really professional customers. So if when they meet, then the customer will understand, will say, oh, I like this project manager, so he's really professional, because without the clear scope definition, he's not giving me the exact numbers. So this guy actually understands what is project manager. But let's say you are dealing with a customer who is not so smart. So in this case, the answer is this, definitely. So let's discuss why there is such a big difference. The difference is between 1 week and 4 months, it's 12 weeks, from 1 to 12. Here I want to tell you about the idea which is called the cone of uncertainty. Maybe you've heard about it. The name is cone of uncertainty. So the idea is that when you start a project, let's say this is the timeline. When you start the project, this is your cost, and this is your time. So and this is where the project will finish. This is the real amount of money which we will spend, the real. So the real amount will be, I don't know, $10,000, for example. Or we're not talking about, we're not talking about money now in this, we're talking about time. So this is time, this is our, the cone of uncertainty is more about money, but we can still, let's discuss it in terms of money, because it will be difficult to draw the diagram. So let's say at this point of time, when we finish the project, when it's actually be finished, then we will know that the actual money we spend is $10,000, for example. When we start the project at this point of time, we can only, that's the idea of the cone of uncertainty, we can only estimate the final result with certain amount of uncertainty. And in the beginning of the project, this amount is, they say, plus 300% minus 300%. So basically, if you think that your project will take a month, which is 4 weeks, then when you start it, you say to the customer that it may take from 4, you take out 3, and you say 1 week, so you go down, you divide it by 4, and then you multiply it by 4. Yeah, you multiply it by 4, so that's the wrong number, 16. So your expectation in the beginning is that it's going to take 4 weeks. But you are allowed in the beginning of the project to go down 4 times and to go up 4 times. That's the idea of cone. Why it's cone of uncertainty? Because it will go like this. So when the time progresses, when you move forward down the road, this uncertainty will go smaller and smaller and smaller. So you are not allowed to say 4 times more and 4 times less when it's half of a project already. So you have more certainty. You know more about what's going to happen, what is happening, and your estimate will be close and close and close to the real number. But when you start, it's allowed to be multiplied by 4, divided by 4. And again, if the customer is professional, the customer will understand that. It's difficult to find such a customer. So not so many people will like this estimate. Not so many people will appreciate you giving these numbers, like from one week to 16 weeks. They will say, what do you mean? That's a little bit too much for me. I don't know how can I work with you, how much I'm going to pay you if your estimate is such a big. But you can explain, you try to explain that there is a lot of uncertainty there. We don't know exactly what you need. You don't know exactly what kind of Tetris game you need. We don't know even the scope. We didn't even start the project. So I'm giving you a huge distance so that you don't blame me later when we go out of budget, when we go out of the schedule. It will be always within these borders, but the borders are too huge. Let us make a few steps forward and I will make it narrow. I will narrow it down. Let me make a few more steps forward and I will narrow it down again. So we're going to reestimate while we move forward through this cone of uncertainty. So we go like this. I answered the question. Yeah, so this is the idea of this cone. So we need to re-estimate regularly, always, going, maybe the end result will be somewhere here, not in the middle. Maybe it's going to be somewhere here, but we still allow ourselves to be, we don't allow ourselves to be wrong. Yep. even, yeah, that's the question is, why do we need to still make such a put such a huge uncertainty, right, into estimate? Why can't we figure out exactly what the customer wants, what is exactly the scope, then go to programmers, make an estimate? It's still going to be not possible. So imagine we're talking about the Tetris app. So I break it down into parts. I decompose the scope. I say we need to develop this Java application, we need to do the design, we need to implement this unit test, we need to implement the deployment procedure, all the different elements I will write down. I will get a list of 10 things. Then I go to programmers and I ask them to make me the estimate. They will provide me the estimate, 3-point estimate. They will give me the best case, the most likely, the worst case. And then I summarize all of them. And most likely, the distance will be close to what I'm telling you. So the programmers will also put a lot of uncertainty there into their numbers. And then when you combine all these numbers together, you will see that the best case is so small and the worst case is so big that the difference will be something close to this. It's not invented by me, that's just coming from the industry, these numbers. Of course, they're just empirically observed, these numbers divided by 4, multiplied by 4. In your reality, it could be smaller, it could be a bit larger. But the idea is that the distance between the best case and the distance and the worst case, it will be quite big. And you cannot just ignore it. You cannot just say, yeah, my programmers told me that the best case is 1 week and the worst case is 11 weeks. But I make my calculations and the middle is going to be somewhere in the 4 weeks. So I go to the customer and say, 4 weeks. Why did you drop this information? Why didn't you show this information to the customer? It's not fair. The customer is supposed to know that your actual numbers which you received from programmers is not 4 weeks. You received the numbers which are lower and much higher. So you show them the full distance. That's the idea of the estimate. This is what professional project managers should do. They should keep the customer informed about the uncertainty which they see in the reality. So I told you that the job of a project manager is to know with very high precision what is the future. And 4 weeks is not the future here. The future looks like 1/16. This is the future. This is your pretty precise, the best you can estimate of the future. So that's how the idea of time estimating looks. And the cost estimating is quite close. We're going to discuss it in the next lecture. But now just remember this cone of uncertainty. And also another term which is related is called rolling wave planning. Rolling wave. It's like the wave which is rolling forward. And you are re-estimating. That's what we just discussed. You're re-estimating multiple times down the road of the project. And if you don't do that, if you stick to the original estimate, then you're just begging for trouble. Because the reality definitely changes. And you need to re-estimate everything, asking your programmers again and again quite regularly. So let's say if your project takes 1 year, then I would re-estimate the whole timeline every month. So we estimated when we started. We just put everybody together. We gave them the estimate spreadsheets. They filled out the information, the numbers. I put everything together, informed everybody. We start coding, and then in one month I do the same. I check my scope. Something changed. I again ask them to re-estimate. They give me the different numbers, and I compare. Okay, how do we move? We move lower. We increase the timeline. How much more we are behind or ahead, and then every month, and you will see how your estimate will go closer and closer to reality. That's the job of a project manager in any project. But most people don't do this. Actually, most people don't do these re-estimates. Unfortunately, most people are ignoring this activity. They just estimate in the beginning in order to get the budget from the customer. Once the budget is there, once the project started, they just say, okay, whatever, we just continue. And the project manager is not doing the job that is supposed to be done in the managing of the project. So again, managing project means checking the reality, doing the reality check, and always putting what's in the reality, putting on the paper. This is the job of a project manager, number one. Not motivating people, not going around the office and mentoring them, not buying them smoothies and free snacks. This is not the job of a project manager. The job of a project manager is to observe the reality, collect everything together, the numbers about scope, cost, and time, and inform the customer. Next question. Some of your programmers complain that they sometimes don't know what to do, that leads to wasted time. How do you fix this? Daily stand-ups, ticket tracking system, regular emails to everybody, and Google spreadsheet. Well, in my opinion, me personally, I like this one. I would suggest a ticket tracking system because it's the most, in my opinion, the most powerful instrument right now on the market. So the second option would be definitely this one, use shared Google spreadsheet like we do, like we have for our class, we have a Google spreadsheet. We don't use ticket tracking system because that would be not very convenient because we want to see the whole picture in one document. In case of programmers, I believe that programmers don't need in most cases to know what other programmers are doing. That's kind of overvalued idea that programmers are interested to know what the whole team is doing. This is what these daily stand-ups are for. So we stand around the project manager or the scrum master or somebody who is the technical leader, and then everybody tells everybody what's going on. I'm going to work today on this feature because blah, blah, blah. Everybody else is just staying, wasting time. That's my experience. So nobody really is interested to know what other people are doing unless this is something that concerns me, unless this is something that bothers me. So in this case, I will just go to that person and ask that person, what's going on? What are you doing? Is it somehow related to me? So placing all the people together in the team and letting them and forcing them to share information about their activities is, in my opinion, is just demonstrating that the management is weak. The management is not capable of really managing. So the manager says, I don't know how to manage you guys, so you just stand around, talk to each other, and this is somehow will manage itself. Instead of saying, no, I am the point of control. I know how to coordinate the flow of information. So I give you the task, you complete it, you return me the results. I give this task to another person, they complete it, return to me. So I somehow coordinate it. Maybe not me, maybe I install the software for this, but I know how to do it. But most project managers, they don't know how to do it. And that's why they invented Scrum. Scrum actually helps them, incompetent project managers, to somehow do the job. So Scrum meetings, the stand-ups, definitely better than nothing. So if you completely keep your people in the dark and they don't know what is happening, then yes, it's wrong. That's a total lack of project management. But the next step, the first level, is daily meetings. The next level, level number 2 or level number 3, is ticket tracking system. When everybody gets, I'm as a programmer, I get my task, I know what I need to do, I know who's going to receive my result, I know who's going to appraise me, I know who's going to say, yes, it's done, and I know who will give me the next task. And this is the job of a project manager, to organize this, to orchestrate this, to define it in the rules of a project. Remember, we discussed the rules. So the project manager should write down the rules on the wall and say, this is how we coordinate our work. But we don't stand up in the morning. That's very offensive, I would say, to programmers. And in most cases, I even wrote an article about this some time ago. So I believe that psychologically speaking, this stand-up meetings is actually the mechanism of triggering guilt in programmers. So some programmers are lazy. It happens. Some people don't really work a lot. Some people are trying not to work at all. Some people are not very productive. It happens. Actually, in the software team, you will have, in my opinion, many people like this. Maybe not half of them will be like this, but these people will exist who don't work. And the problem of a manager, I think it's one of the biggest problem of all project managers, is what to do with these people. So there are actually 3 kinds of people in any team. We're going to discuss people in some of the next lectures, but just a quick summary. So there are basically 3 kinds of people in every team which you will manage. The people who are top performers, who just love to work, who will work even if you don't manage them. Even if you just walk away, even if the project is closed, they're still going to work. They love to work because they're just very productive and they're very effective. They're very full of energy. That's one category of people. There are not so many of them. Another category is the people who don't work. It doesn't matter what you do with them, how you manage them. They always will trying to be lazy, trying to get away from the work, trying to put their work to somebody else. They're just people who don't produce. And the people in the middle. The people in the middle are not top performers. They're okay. They can do what you tell them to do. But if you don't tell them what to do, they will do nothing, more or less. They will talk. They will walk around the office. They will spend their time having fun. They're not lazy people. They're not trying to push back everything you tell them, but they're not very active. They're by themselves. So the problem of the management is what to do with these 2 categories at the top and the bottom. So how to not to lose A people and how to lose or make them work the category of the C people, the A, B, C. So the A people, the biggest problem for a project manager, if the A people will quit. So if you don't manage them right, if they don't give them interesting tasks, if you don't organize the work in the project properly, then these guys will just quit. They will find another job, they will find another project, and that's a huge damage to the project. And these people are also a big damage because they don't do anything and they affect other people. If you don't do anything with them, if you ignore them, if you don't pay attention to their laziness, then they will, then the people who actually work, they will see that the project doesn't care about zero performance. So why should I work if nobody cares about people who don't work at all? And then again, the A people may quit if they see that the project manager doesn't care about the C people. So your job is to care about these two categories, how to motivate these guys and how to kick off these C people. So getting back to the ticketing system, so when you do the daily stand-up, when you put the pieces together in the room, this is an instrument to do something with the C people. Because they will feel guilty if they keep saying every day, I didn't do anything yesterday, I didn't do anything yesterday. So everybody will just look at them and kind of shame them and blame them. It's called also peer pressure. So they will push, they will put the blame, the guilt will get triggered. The feeling which is deep inside of us. So we don't feel comfortable telling other people who actually work that, you know what, I didn't do anything yesterday. Well, you can do it one time, but if you keep doing it every day, then you will feel ashamed and you will start, the hope is that you will start working. But again, I don't believe in that. I don't think this is a good instrument for a proper project manager. The proper project manager, the good project manager, gives tasks to everybody. Everybody completes the tasks. We collect the results. We put the metrics on the board, and we put the board on the wall where it says this programmer is an A programmer, this one is a B programmer, and this one is a C programmer. And then by the end of the month, we just fire C people, and that's it. Or do something with them. Maybe, I don't know. It's up to you what to do with them. Maybe you don't need to fire. Maybe you need to help them do something. It's your job. But it should be visible on the screen, not in the meeting where we just subconsciously somehow, without being explicit, we just expecting people to get the feeling. This is not a good instrument for a project manager. So this is definitely not. Ticket tracking system is yes. Regular emails to everybody. Well, emails, it's not the mechanism of 2023. It's the mechanism of maybe 1995. So it's we don't use them anymore for management. So definitely not emails. Nobody reads them. Nobody answers them. It's gone. This technology is for something else. This spreadsheet is more or less okay, but I would suggest ticket tracking system. Number 5. There are 5 activities taking 2 days each. How long will the entire project take? What's your answer? I think it's clear, right? Yeah, the answer is 4. That's obvious. You're smart enough to understand that. So we have activity 2 days. They may be located like this. They may be located like this. Actually, maybe even this is not the right answer because, now I understand. I wrote this answer just this morning, but maybe they will be located like this. So this is 2, 2, 2, 2, 2. But the distance here may be also a few days. So it doesn't mean the activities, they go head to head. They go head to tail. Maybe there will be distance between them. For example, there will be the weekend between them. So the 10 days is not a guarantee, right? So actually the real number, it was, I don't know here. In your version of the slide deck, it was I don't know. And that's the right answer, I don't know. So 10 days is definitely not the maximum duration of the project. So why I'm saying this? There is a mechanism of scheduling the project, of building the schedule of the project. And this mechanism is called PDM, precedence dependency management. It's where you ask your programmers, ask your people in the team to estimate how long will each task take. So you get 2 days, 2 days, 2 days, 2 days, 2 days, and then you ask them who depend on who. And they will tell you, I do it, this will take me 2 days, but I need this activity to be finished first. So for each activity, you will have a picture like this. It's going to be
This is my activity, but I have dependencies which are formulated like this. This is, for example, activity A, and this is B, and I say that B, this dependency is called finish to start. So B depends on E. When A finish, then B can start. There could be another dependency. For example, there's another activity called C, and I say that B must finish. B must finish. So this is the dependency called finish to finish. Finish to finish. As you can see, there are 4 types of dependencies: start to finish, finish to finish, finish to start, start to start. So they may be, in this case, I'm saying that the B must finish only after the C is finished. It's not very typical type of dependency, but it still may exist. So my activity may only finish only after that one is finished. So I need to wait until this one is finished. And then you put these dependencies between all the 5 activities. You just write them down without the graph. And then using this PDM technology, you draw the graph, you draw the diagram where you put all the activities together, and finally you get the duration. And the duration, imagine that here when we say 10 days, we just assume that all activities depend finish to start, finish to start, finish to start, and they have 0 lag. 0 lag. Lag is the distance in this activity. So we can say finish to start, the lag is equal to, I don't know, 5 days. So my lag, so I finish to start plus put 5 days in there. So I need to start. So B can only start after A, but 5 days to wait after A is complete. In this case, our total duration will be, of course, longer and longer. So this is the mechanism which you can learn yourself how to do it. It's quite simple mathematical mechanisms. You put all the activities together, you make the connections between them, then you calculate me the full picture of how long will it take and what goes after what. And then you build it. So this is your job as a project manager. Well, actually, this happens with the software. So nobody does it manually anymore. So you just put it into some software. For example, Microsoft Project can do it for you. You just put all activities there. You say who depends on who, what are the dependencies. Then it calculates it automatically for you and makes you the shortest possible duration of the entire project. Simple as that. What do you see on the picture? So who gave the right answer? Who knows the right answer? Option 4. No, the right answer is 2. Yeah, it's called critical path method. It's very important to understand the idea, not so important to understand the picture, but actually nothing is difficult. So if you look at this picture, we have 4 activities here, A, B, C, D. It's already calculated who goes after who. So we already put them on the graph. We know the dependencies. So this step is done. And these are the numbers. So this one is, this is when the activity, on which day, let's say it's the days of the months. So this is 1st of January. So the activity A can start the earliest on the 1st of January. So we cannot start earlier than the 1st of January. This is the number stays in this particular rectangle. We can finish this activity at most on the 5th of January. So we start on the 1st, we finish at most on the 5th. The duration of activity is 5. The 5 days duration. Okay? I'm just explaining you what are the numbers in these rectangles. So all rectangles are the same concept. This is the latest day when the activity can start. And this is the latest day when the activity can finish. So for each activity, we kind of give the possibility to move in the schedule. Now, you see that this line is bold and this line is bold. This one and this one. This is called the critical path. So if you put all activities on the diagram, then you will see that some of them will be on the path which you cannot move. This critical path, they will go head to tail. So they will go one after another on this critical path. While this activity can be moved a little bit left, a little bit right, in time. Why? because the duration of this activity is 5 days, and the duration of this activity is 10 days. But they depend, so the D activity can only start after C and only after B. But B is smaller and C is longer. So B can move like this. You understand, right? So it can be moved. So this is the critical path, this one, and this is not. This is the flexible path. I don't know what's the right name. The critical, or the opposite is the flexible or something. No, non-critical path. So the critical path is something which we cannot move. And this is the most important connection of activities in the project, because they actually define how long is the project. So the total duration of the project will be 5, 10, and 15. 5 plus 10 plus 15. So all the durations of all activities on the critical path. You put all these durations together and you will get the critical path. So the job of a project manager, in order to do something with the schedule, in order to do something with the total duration, is to work with the critical path activities. Because if you optimize the duration of B, you're not going to help the project anyhow, right? We don't really care. If you deal with the B, make it instead of 5 days, it's going to take 4 days. Who cares? It's still not on the critical path. The duration of the project will stay the same. Because the critical path activities, you don't move, you didn't change them. So project managers, the number one job of a project manager is to define, well, number one job in the time management, to define what is my critical path, who stays on the critical path, and then deal with these guys, because they are important. You can hear this term sometimes in the management, critical path, or maybe just in a time management, the personal time management. So for the project manager, it's very important to make sure that the people who do the activities on the critical path, you talk to them, you control them, you make sure that you know what's going to happen with them. But who does this task, it's less important for you. You can ignore it, you can let it happen, whatever. Because if they, for example, fall behind the schedule and instead of 5 days, they spend 7 days, it doesn't affect you anyhow. So when they do huge projects, like they fly on a different planet or they build some huge software, they define this critical path and then they sit together and say, how can we make sure that these tasks which stay on the critical path, they actually will happen in time, that we don't lose the time there. And there are many different paths. There could be a number of critical paths, well, if they're the same length. But usually it's one critical path which goes through the entire diagram. And you deal with this critical, and this is the method, which is called critical path method. The people who invented this critical path, they suggest a method for this structure of these rectangles and how the numbers to put there and how to calculate the critical path. It's not a trivial task for somebody who doesn't know what should be done. But if you do know, you can build this critical path. You can try it out in your project. Write down 10 activities, 10 things that need to be done. For each, this is going to be your homework. For each activity, you define the duration, you define dependencies between them, you define who depends on who, in which situation, what are the legs. The legs means, like I said, the distance which you may waste, this time you can wait, and then try to draw this diagram. Try to do and define which is the critical path. It's should be simple, but at least once you must do it to understand what it is. What is Gantt chart? You probably know. Gantt chart is a simple representation of the timeline. So when you have activity, I don't know, A1, A2, A3, and then that's your time. So for A1, you say, I'm going to do this here. Here I'm going to do A3, and here I'm going to do AB, and here is going to be A3. And these are my days. So this is my week number 1, and this is my week number 2, this is my week number 3. So this is Gantt chart. And in the Gantt chart, you can draw dependencies. You can say this one, like this, for example, which means this one should start before this end, for example, with a lag of 3 days. Here you say 3 days. And this one, for example, must finish, this one must finish before that one finishes. You define these dependencies, and Gantt chart is just a different representation of the timeline. Microsoft Project uses Gantt chart, but it can also, to my knowledge, can also draw you that kind of diagram. So these are the methods of optimization. But Gantt chart is more visible, more visually understandable by the business people. So if you show this one to the business people, they will be very surprised and they will not understand what you're talking about. If you show this, we are more accustomed to that kind of visualization of timelines. And this information will be accepted more easily by the customer. Project schedule is not a diagram. Project schedule is an aggregation of all of that. So project schedule actually includes the Gantt chart and includes the critical path method diagram. So project schedule is like a document where everything is defined, where we put the estimates information. So we say we had 10 activities, so we collected the estimates from programmers, so these are the numbers that they provided. Then this is how we draw the critical path. That's how we define the critical path. And then this is our Gantt chart. That's the schedule, we put it on the paper, we stick it to the wall, let's work. And we call it schedule baseline. That's a term from project manager. We call it schedule baseline. Schedule baseline is something which we draw and signed off. And everybody said, yes, we commit to this, we're gonna work like that. It doesn't mean that it's gonna stay on the wall till the end of the project. It's gonna stay maybe 1 week. We remove it and we create new schedule baseline. But this baseline, it's a term from project management, it means something which we fixed. It's a baseline which we don't move. So we agree that this is how things will happen. But we can change it. But every time we change it, we say the baseline was 75 days. Now the new suggestion is 79 days. So the difference from the baseline is plus 4 days. Do we accept it? Everybody says, yes, we accept it. Okay, we do it. That's the idea. But we always have a baseline. So we must, as a project, the project manager must have a baseline. And the baseline must be signed by the customer. Well, ideally by all the key stakeholders. So your job as a project manager is to put everything you see from the reality. So you talk to programmers, they told you it's super difficult, we're not going to do it, I don't know how much time. Okay, you put all the information together, you make an estimate, you say, okay, it's going to take maybe 4 times more, maybe 4 times less, all together, this is our critical path, please sign it. And the customer says, okay, I agree. Until it's signed, until you have the baseline, the project manager doesn't move forward. You don't make a step forward. You don't do anything. You don't spend a dollar of the resources of the project. You wait until the customer says, yes, I agree with this baseline. Then you start spending money, start spending resources, giving people the tasks to do. And something changes, you redo the baseline and do it again. Question number 7. A customer asks you to complete the project 1 month later, faster. How can you do this as a project manager? Option number 1, well, the right answer is, you probably know, right? Which one? 4, 3, 2? Okay, interesting. The right answer is 3, crashing and fast tracking. I will understand you what it is. Of course, definitely option number 4 is the joke. Pay and pray, it's a term which I've heard a lot in the community of investors. This is how they say when they give money to the startup, they say pay and pray. It means I invest into the startup and then I pray that they will actually do something. But in most cases they don't. So you pay somebody and again you pray and again no result. So that means you have no control over the reality. You pay and pray. So you just give the money and have no influence. You have no any instruments of control. Of course, we are as project managers, we don't do that, we don't pay and pray. This is not an option for us. Option number 1, smoothies and free snacks. So that means a lot of motivation, a lot of rewards for people and then asking them to work probably on weekends or overtime, right? Because how can you make it faster? We already made a schedule baseline. We already asked everybody, how long will it take? They already gave us the numbers. We already draw the diagram. We put everything on the Gantt chart. We calculated the critical path. And then the customer says, make it one month faster. It means what? Yeah, of course, they not even can, they do it. Yeah, that's exactly right. Yes, they already agreed. Yes, exactly. But in this case, they say, they ask you, but it doesn't mean that we are not, as project manager, we're not allowed to make changes to the project baseline. So when they ask us to make it faster, so our job is to say no and suggest a solution. And that's we discuss now. What is the solution? So how can you? What can you propose to them? So maybe you can say, okay, it's going to be 1 month faster, but will be less scope, or it's going to be more money, something like this. So you change something with your baseline. So the project must be flexible. So of course you should not stick to what was agreed upon 6 months ago. And then say, you just said 6 months ago that we're going to do it this way, and we're not accepting any changes. In this case, the customer will be super unhappy, and this is not how we manage projects. So we are okay to changes, but every change which is coming to us, we just recalculate the situation. We re-estimate, replan, redo something, and then suggest new format, new way of, new reality. So the customer knows one reality, and then he comes to us and say, please change the reality to me, make it happen 1 month earlier. And we say, okay, let me build a new picture of the reality, and I will show it to you. And the new picture will look like this. In this case, it's not going to be $1,000, it's going to be $1 million. Are you okay with this reality? And the customer will say, no, forget about my idea, keep doing it the way you were planning to do. So now our question is, what do we propose? So in this case, you're right that these two options are actually not good because we're not changing the reality. We're just trying to use the existing team, the existing project, the existing planning, and somehow, encourage people to do more than we planned before. And that's not the right idea in general. So you don't do it like this because, yes, in this case, you don't change the reality, you don't replan, you don't rebuild the project baseline. So with the option number one, you give people some encouragement, some rewards, expecting them probably to work overtime, to work on the weekends, to work overtime, somehow to work faster. But usually it doesn't help. People cannot. Well, in most cases, you will fail on different levels. People will be unsatisfied, the quality will suffer, probably some scope will be lost. So this is not a good idea to work on overtime and to ask people to do it. Option number two, again, it's related to people, so you motivate them or you punish them, you motivate them. This is irrelevant to schedule planning. This is irrelevant to time planning, all of this. The customer is asking you to change the timeline, to change your time expectations, your time estimate. And your job is to do it. So you use these two techniques, crashing and fast tracking. I can explain you what it is. Let's start with crashing. So let's say this is your timeline. This is your critical path. So we need to implement feature number one. And then after that, we fix bug number three. And at the same time, we fix bug number 4. This is longer. And after this, we fix bug number 5, and we implement feature number 2. This is our timeline. And we know that the critical path is, maybe let's do it this way to make it more, like this. So we know that this is our critical path. Right? So this B4 and B5, we can move left and right. They're not so critical. But these guys, B3 and let's say B7, so they go in one line. So they need to be implemented. So let's say this is 2 days, this is 5 days, this is 2 days, and this is 2. So the total duration of the project is 2, 5, 2. It is 11 days. And the customer comes to you and says, no, from 11, please make it 6. So now the question, how do we do this? We can start asking people who are assigned to these task numbers B3 to make it, instead of 5 days, make it 2 days. But this is not a good idea. We don't do that because, like I told you, it's a long discussion maybe, but you don't force people to work faster as they can, as they estimated. What do? You can do crashing. Crashing means you break down a task into two tasks, B3 prime. And this will be 5, and this will be 3 days. So when you crash them, then it will be a possibility to recalculate the whole pass, and there will be a new critical pass because the dependencies will change and the duration will be shorter. So that's the idea of the crashing. Maybe I cannot show you visually how it looks. It will take more time. But that's the idea. So you take a task and crash it into multiple tasks. And once you crash it, you get a new picture on the diagram, and it can be recalculated and compressed because you crashed. So you removed one of the items from the critical path. It was a big item. It was holding the critical path, and we had to go through this item. Once you crash it, the critical path may potentially be recalculated. How do you crash it? You just go to the programmers and say, you're working on this task for 5 days. How about you do this one first and then that one first? So we split it into a number of tasks. And they say, okay, in this case, you assign maybe 2 different people to this task. The resources will be freed, so it will be possible to recalculate, because each task, they usually, why the tasks, they depend on each other? Because of resources. So why it may be possible that the task B depends on the task A? Because the task B requires one programmer, and this task requires the same programmer. So they cannot go in parallel. They have to go like this. But if you crash this task into 2 pieces, then you will get this task to one programmer, and this one maybe to potentially another programmer. In this case, the resource dependencies will be avoided, will be removed from the picture. And you will be able to recalculate the whole schedule. Right? So that's called crashing. And fast tracking, it's another technique where you take, if I'm not mistaken, I thought I knew that, but fast tracking is when you take one task and put it in parallel with another one. So instead of this, you just put B3 prime here, like this. In this case, you also make the critical path shorter. So crashing is taking a task, breaking into pieces. Fast tracking is putting them in parallel. They were staying like this, and you're thinking, okay, do they really need to go one after another? Maybe we can somehow help them go like this, help them not depend on each other. So this dependency, head to tail, or finish to start, we remove this dependency and introduce some other dependency. So they will go in a fast tracking mode. So crashing and fast tracking, there are 2 instruments of so-called schedule compression. That's the term, schedule compression. So when the customer comes to you and says, make it faster, you say, okay, now I'm going to do schedule compression. So I'm going to compress my schedule. When you compress it, maybe you will tell your customer, you know, in order for me to make fast tracking, give me another programmer. Now I have 3 programmers, 4 programmers. Give me another 2 programmers, and it will allow me to do fast tracking. Because now the tasks depend one after another. I have just, let's say you have just 1 programmer. In this case, you're going to have all the tasks like this in one line. One programmer will do all tasks one after another. You cannot do any crashing. You can do crashing, but it's not going to help you. You will just crash, crash, crash. You will have many micro tasks, but they're also still going to stay in one line. And then you tell your customer, you want it faster? Give me another programmer, and I will do fast tracking. Some of the tasks I will assign to different people. And then some tasks will go in parallel, and I will get the critical path will be shorter. Give me another 2 programmers, and I will be able to do more fast tracking. First, I will do more crashing, so I will give them the tasks, and then fast tracking will enable me to parallelize, to make some tasks in parallel. So that's how you deal with fast tracking. And every time you go back to the customer and say, you know what, you give me more resources, you pay more salaries for programmers, so the budget will go up, but the timeline will be shorter and shorter. And the customer will accept it, or they will say, no, I understand it's more expensive, so get back to the original baseline. So don't change the baseline. So while you discuss this with the customer, everybody works as before. So you have the baseline, you have it on the wall. The baseline says, this is our critical path. Everybody continue working. Then the customer comes to you and says, it's too long, I need it faster. You say, okay, let's discuss. But everybody continues working. Then you discuss, and the customer says, maybe I will approve, calculate me the budget. You do you calculate a new number, and then the customer says no. You say no problem, you get back to the original baseline. Or they say yes, you approve the baseline, you put the new baseline on the wall. Final question, which of the following belongs to the SMART acronym? What's your answer, friends? You said you know. 4. Right, you're right. Number 4. That's good. So smart, that's not actually about really project management. It's more like a folk term that's suggested by the industry people. So yes, so who knows what it is? What SMART stays for? The SMAR. Specific. That's right. Specific, measurable, achievable, relevant, and time box, right? Well, actually, there are many other interpretations of this SMART acronym. So some people say that there could be other words there, but I'm not sure which are. I cannot give you examples. So yes, so when you give a task to, let's discuss the time boxed. I care about this one because we're talking about time management now. So time boxed means that you give the task to somebody, and you as a time manager, you always say you start working, and then when your time is finished, then you stop at this point. This is what is a good approach to time management. So instead of saying, well, there are two approaches actually. You can either say that you work on this until you finish it. For example, the bug. So you ask the programmer, fix the bug. You don't know exactly how much time it will take. Well, the programmer told you 1 day. But who knows, right? The programmers, they cannot guarantee you anything. So you tell them, fix the bug until it's fixed. And then it's fixed in a week. So the programmer was working 5 days instead of 1 day. Or you tell programmer, start fixing. If you don't fix it in 1 day, you come back to me and I decide what to do. Maybe I will give you another task which will sound like continue fixing the bug. Maybe I will tell you, stop doing this, do something else. So it's going to be my decision. So I believe that this is not me. Everybody believes that this is the right project management. So you don't let programmers continue over the time. They should return back to you and tell you that I am over time. My time is over. I didn't finish. It's not a problem. We shouldn't blame programmers for this. And they should understand that we don't blame them for this because it's an unpredictable kind of work. We don't know how much it will take unless the scenario is very simplistic and very primitive. But in real life, in real programming scenarios, most tasks we just cannot complete on time. For most problems, we just don't know how much they will take. We only estimate. So that's why we ask programmers, we clearly separate responsibilities. We say, I am the project manager, you are the programmer. So don't do my job. Don't decide that it's okay to continue over time. I told you, you start in the morning, you finish in the evening, and then come back to me. But usually programmers, they feel like they must continue until they finish. They just feel responsible for that. They think that's a good attitude. They need to make the full contribution, work on the weekend, work on the overtime until the problem is fixed. This is wrong. You as a project manager need to convince them that this is the wrong attitude. Instead, they should come back to you and say, my time is over. What should I do? Continue or stop doing this? Maybe I'm not competent enough for this task. Maybe you can find somebody. I don't care. It's your job as a project manager. I was honestly working with the problem. I was not watching Facebook. I was not doing something else. I was focused on this particular problem. The problem is not solved. But the job of a programmer is to inform you. Most people who I work with, they don't do this. Most people, they just don't inform. And it takes a lot of energy to teach them that this is how they should be doing the management, the self-management, time management. Usually they just continue. And more interesting that they continue and then at some point of time they take some other task and continue with another task. And then you come to them in a few days and ask, what are you doing? And they said, I finished that task already. I picked another one. Don't worry about it. So they take the job of a management by themselves. They believe that they're competent enough to manage their own time. They don't care about the project management level. They just do what's interesting for them. This is how programmers work. So your job as a project manager is to teach them, no, don't do that. Stop and inform me. And then you will get the clear, timely information from them, and you will be able to decide to continue or to stop, to continue to stop. And the shorter the tasks, that's my final line for today, the shorter the task you can give, the smaller the task in time you can give to your programmers, the higher level of management you are. If you give them tasks like 2 weeks of work, you're not really a project manager, you just putting the responsibility of the work of management on their shoulders. You should give them tasks. We give tasks in some of our projects of 30 minutes. 30 minutes. You work for 30 minutes. When it's done, you come back to me. 30 minutes. But we use robots. We use computers for that, for automated management. But this is, in my opinion, fine-grained, top-level management. 30 minutes. The programmer starts, makes an attempt. Something works. Good. It doesn't work. We close the task. We start another one. So we switch between tasks very often, and we close tens of tasks every day. Not just waiting for one task for a week. So the smaller task you can give to the programmer, the better management you are. And I also made a picture here for you about the critical path method. I found it in Wikipedia, so you can study it yourself, but that's exactly what I was telling you. I didn't understand what is drag, or I forgot about that. So you can learn it yourself, what is drag. This is duration. DUR, they call it duration. These are the tasks. So this is the red one, is the critical path. You see, the critical path goes like this. So these guys are not on the critical path. Same diagram. So draw it for yourself. Make it for yourself. You will have fun. It's interesting. At least once you need to do it. I did it. I remember I was studying for the PMP certificate. So I did it a number of times, but then I forgot. So finally, the homework. So what I suggest you to do during your labs, I suggest you to create a project schedule. So imagine you have a project, or take your real project. So make a project schedule, 1 page. Make it short. 1 page, maybe 2 pages maximum. But in this project schedule, show me the Gantt chart, show this critical path method. So find the critical path among your tasks. So your project schedule probably should start with, this is the list of tasks which need to be done. This is the estimate which we collected from programmers. Use 3-point estimate. This is how we put these activities, which one depends on which. And then this is our critical path. So how we draw the critical path. And that's our schedule baseline. So we work like this. Make it short, 1 page. Imagine that you have real people who will read this document, so it should be absolutely clear. Remove the noise, remove all the unnecessary information. Just clear list of activities, the diagram, the Gantt chart, or the critical path method.